Hello and welcome to AP Test Review. Today we're going to discuss some more probability concepts, namely two events, how to organize them in the probabilities of them occurring into either a two-way table, also called a contingency table, and a Venn diagram. So let's start off with this scenario. The most important question that 2019 posed to society was, which chicken sandwich is better? A group of U.S. adults were randomly selected and asked which chicken sandwich they preferred. Popeyes' new chicken sandwich or Chick-fil-A's original chicken sandwich? 53% said they preferred Popeyes only, 31% preferred Chick-fil-A's only, and 7% said they did not like either sandwiches. So we have enough information here to arrange these probabilities into a Venn diagram and a two-way table. I'm going to do both of them for you. Now what we have here is we have two variables, Chick-fil-A, whether or not Chick-fil-A sandwich is preferred, and another variable, whether or not Popeyes is preferred. So what I'm going to do for Chick-fil-A, that's going to be event C, the preference of that. We'll call that event C. And Popeyes chicken sandwich is going to be event P. All right. So I'm going to do Chick-fil-A as my row variable. So people can respond that they prefer Chick-fil-A or they do not prefer Chick-fil-A. I'm going to call that C prime. That's the complement. And then the column variable, I'm going to do Popeyes. They can either prefer Popeyes or they do not prefer Popeyes. I'm going to put some totals in here for my marginal values. Now the data was expressed in percentages, and I'll show you how to deal with counts here later. So I'm going to, the information that I've been given, I'm going to put in red, and then we're going to use math to find the other cells in our two-way table. So I know that 100% of these people will be represented, or their response to this question. I know that 53% said they preferred Popeyes only. So I have to go to my Popeyes column and go to the cell where Popeyes and not Chick-fil-A join, because Popeyes only means they only prefer Popeyes and do not prefer Chick-fil-A. And that's going to be 53%. It's called a joint frequency. It's because that's where those two events, they both need to occur. For a person to only prefer Popeyes means they prefer Popeyes and they don't prefer Chick-fil-A. So that's that joint frequency, 53%. I know that 31% prefer Chick-fil-A only, so I'm going to have to go to Chick-fil-A, where Chick-fil-A meets and Popeye Prime meets, and that's going to be 31%. And then I know 7% did not like either, so that would be C prime, P prime, not Chick-fil-A and not Popeyes is 7%. Okay, now with math, I can build or find the rest of my frequencies. So for Popeyes, or people that did not like Popeyes, I just add 31 and 7% to get 38%. I know that 62 plus 38 is 100. So Popeye's total is going to be 62%. I know that 9% plus 53% is 62%. So that would be the people that preferred both Chick-fil-A and Popeyes. And then I can total this will be 40% for people that preferred Chick-fil-A and 60% for the people that did not prefer Chick-fil-A. Total for Popeyes is 62%, and the people that did not prefer Popeyes is 38%. I have all the information I need in that two-way table now to answer pretty much any probability question you throw at me about these two events. You can also use Venn diagrams. So I'm going to go ahead and let's see. So since we have two events, we need to create, and they do overlap. People can actually like both sandwiches. I'm going to call one of my circles P for Popeyes and C for Chick-fil-A. Now, I would always recommend starting with the intersection first, the people that prefer both equally. That wasn't actually given to us in this scenario. I was given the people that don't like either, and that goes on the outside, but still inside the box. So this box needs to contain 100% of the people surveyed. Popeye's circle needs to contain all the people that preferred Popeyes. Chick-fil-A circle needs to contain all the people that prefer Chick-fil-A. So I do know that 53% preferred only Popeyes. So that goes in the Popeyes circle, but not in the overlap. I know that 31% favored only Chick-fil-A or preferred only Chick-fil-A. And then if I needed to find this overlap, I know that 53 plus 31 plus 7 plus whatever is in the middle has to add up to 100. So I can just take those three numbers, subtract, and I find out that 9% are unaccounted for. So those are the people that prefer them both equally. So now I've got that set up. Now, just so that you have some background, if I'm going to highlight 53% here. Symbolically, with probability notation, that number would be the probability of Popeyes and not Chick-fil-A. This number, if I was to write that with notation, would be the probability of Popeyes and Chick-fil-A. And this number, if I was to write that, would be the probability of Popeyes, not Popeyes, and preferring Chick-fil-A. And then 7%, I can write that with probability notation as well. It's the probability that they don't like Popeyes and they don't like Chick-fil-A. It's good to know the different notation. Now let's go up here. There's two. We're going to be dealing with finding the probability that both events occur. Both is generally your context clue, or you could also interpret that as probability of P and C, and that is denoted by this intersection sign. And then you'll be asked to find the probability that one or the other event occurs, and that's the union sign. Now we will be using, you'll be given the formula sheet for the AP test, and we're going to be using some of those formulas today. Actually, you know what? On your AP formula sheet, the two we'll be using today, I'll write them down here, but you should always have this close to you. There's two that we'll be using today. The conditional one, which is the probability of A and B over your condition. And then we'll also be using the addition rule, general addition rule, the probability that one or another event occurs. So union, which would be probability of A plus the probability of B minus the probability of both. Now, simplistically speaking, conditional probabilities generally give students a difficult time. Oh, let me fix this. This should be a probability of B. I like to think of it as what a conditional probability is let's just look at the A given B right now. We have knowledge of B occurring. How does that affect A? So if I was to read this right here, I would be, what is the probability of A given that B has already occurred? So we have knowledge of B. So just think of that as the probability of both of them happening over the one that we have knowledge of previously. So I'd say it's both over the condition. And the condition always comes after that vertical line that reads as given that. All right. So those are the two formulas on your formula sheet that we're going to be using today. So let's dig in a little bit and solve some problems. Okay, what is the probability that a randomly selected U.S. adult likes both sandwiches equally or has no preference? So I'm going to write that with notation first. So that would be Popeyes and Chick-fil-A. Now, this is a joint frequency. I can pull this right from my table. Go where P, oh, I didn't want to write prime. Sorry about that. Let's redo that. Probability of Popeyes and Chick-fil-A. So I want to go where P and C meet, and that's 9%. Again, that's called a joint frequency. And as long as you have a table or Venn diagram, you can generally pull these right from the table or Venn diagram. Here it would be right there on the Venn diagram. I want you to think, when you get these, we need P and C to occur. So think when these two join. That's why they're called joint frequencies. In the displays above. All right. Moving on. What is the probability that a randomly selected U.S. adult does prefer Popeyes or, there's my context clue, does prefer Chick-fil-A? So this is a union problem. Does prefer Popeyes, so P or Chick-fil-A. Now, I gave you the formulas below in the forms of A and B. You just have to substitute P in place of A and C in place of B. So I need the probability that they prefer Popeyes, plus the probability they prefer Chick-fil-A, minus the probability they prefer both. You might be wondering why we're doing that. These people here, the ones that prefer both Popeyes and Chick-fil-A, are also included in the total of probability of people that prefer Popeyes and the probability of people prefer Chick-fil-A. So they've been counted twice. They can only be counted once, so we just have to subtract them out once, so they're only reflected in the probability one time, and they're not double counted. So the probability of Popeyes, so go to P up here on your table, go to the total for Popeyes, and that's 0.62. Here, Chick-fil-A, go to the Chick-fil-A, that's 0.4. Go to where they meet, P and C, that's 0.09. Go ahead and add, subtract, you're going to get 0.93. And that should have sparked, if you would have just did 62 plus 40, you would have 102, and we know that's not a legit probability, so that should have raised a red flag. And that's because that 9% are included in the 62 and 40. We only want to include them once, so we subtract them out once, and then they're only represented one time. Okay. What is the probability that a randomly selected U.S. adult does not prefer Chick-fil-A? So I'm going to start writing this out now so I don't get confused. So it's Chick-fil-A prime. And does prefer Popeyes. This is another joint probability. We should be able to pull it right from the table. So C prime and P, where they meet. C prime and P, there it is, 53%. Okay, here we go. Given that, this is a context clue. This tells me I'm going to have knowledge of something happening first. That's a condition. What is that condition? That tells me, okay, this is conditional. Given that a randomly selected U.S. adult does not prefer Popeyes, so I'm going to do given that, does not prefer Popeyes. What is the probability they prefer Chick-fil-A? So that's what I'm finding. The probability someone prefers Chick-fil-A, given that they do not prefer Popeyes. Remember, that's the probability they both occur, so C and P prime, over the probability of the condition, which is the one that is you have previous knowledge of. So that's going to be given that they do not prefer Popeyes, P prime, the probability of P prime. All right, so I can pull C and P prime. Actually, I just found it. Oh, no, I didn't. So go to C and P prime, it's 0.31. And then probability of P prime is 0.38. Divide, and I have my answer, which is 0.82. Okay, here we go again, another conditional statement. Given that a randomly selected U.S. adult does prefer Popeyes, what is the probability that they do not prefer Chick-fil-A? So again, probability that someone does not prefer Chick-fil-A, given that there's knowledge that they do prefer Popeyes. So that's going to be, again, the probability they both occur. So C prime and P over the probability of P. C prime and P, I calculated that earlier, that's 53%. And P, I can pull that from my table, go to P, go to total for P, 0.62. Divide, and I've got my answer. Okay. Now, you could be, I jumped ahead a little bit. I was getting into the next question already. Are the events preferring Popeyes, so that would be event P, and not preferring Chick-fil-A, that would be C prime, are they independent? Now, a lot of students just want to say yes or no, but they don't mathematically back that answer up. So we can. So the probability that Popeye happens, if C not preferring Chick-fil-A does not affect the probability somebody prefers Popeye, then I can solve this statement here. So if C prime doesn't affect P, then the probability of P should remain the same. So if I find the probability that they both happen, so P and C prime over P of C prime, that should remain equal to the probability of P. Now, let's substitute numbers in place. So P and C prime is 0.53. Probability of C prime is 0.6. I divide. I set that equal to the probability of P, which is 0.62. I will find out that those are not equal. So now I'm going to also solve this one too. So if knowledge of Popeyes does not affect whether or not they do not prefer Chick-fil-A, then I should ring true. There we go. So I'm going to solve, this would be C prime and P over P of P, and that should be equal to P of C prime if they're independent. All right. So C and P prime, again, is 0.53. Probability that someone prefers Chick-fil-A is 0.62. And that should be equal to the probability that they do not prefer Chick-fil-A, which is 0.6. So those are not equal. So I've solved both possibilities, or both ways. And I find that they're not equal, so they're not independent. They are influencing each other. Knowledge of one does affect the probability that the second event occurs. Okay, now you can handle the data given to you as counts. Can you handle the data given to you as counts instead of percentages? So we'll run this scenario again, and instead of giving you percentages, I'm going to give you counts, and we'll do it that way. Again, the most important question that 2019 posed to society was, which chicken sandwich is better? 185 U.S. adults were randomly selected and asked which chicken sandwich they preferred, Popeye's new chicken sandwich or Chick-fil-A's original chicken sandwich. 78 said they preferred Popeye's only, and 53% preferred Chick-fil-A's only. 29 said they liked them both equally. So again, I'm going to use, what did I do in the previous? I'll just do, okay, so I'm going to put Chick-fil-A, Chick-fil-A no, Popeye's no, and then some totals. Okay, and now I know my total for the table total is 185. And then what information was I given? I was given that 78 said they preferred Popeyes only, so go to Popeyes and not Chick-fil-A and put in 78. 53 preferred Chick-fil-A only, so go to Chick-fil-A and not Popeyes, put in a 53. And 29 said they preferred them both equally, so people that like Chick-fil-A and Popeyes, where those two meet, is going to be 29. Now I can use my math skills. 29 plus 53 is 82. 185 minus 82 is 103. 103 minus 78 is 25. 53 plus 25 is 78. 185 minus 78 is 107. And I would just make sure that those work both across and down. All right. Now again, I can arrange this in the form of a Venn diagram. Okay. Right. So Popeyes, Chick-fil-A. Now, again, we do have the probability they prefer both equally. I would always start with your intersection first and work your way out. So then I know 29 out of 185 prefer them equally. So now this is where students do tend to run into some difficulties. Now when I do Popeyes, I already have 29 in here, but this is 53%, or 78 said they preferred Popeyes only, so then I know that's 78. If they would have gave me the total for Popeyes, I would have had to subtract out that 29, because there was already 29 people accounted for. So 78 out of 185. And then 53 preferred Chick-fil-A only out of 185. Okay. Now there's some people unaccounted for. These 78 plus 29 plus 53. And then subtract that from 185, and I find out that 25 out of 185 do not like either of the chicken sandwiches in this particular case. Okay, so now let's work with counts instead of percentages. Okay, what is the probability that a randomly selected U.S. adult likes both sandwiches equally or has no preference? Again, it's the probability they like ooh, all right, what's going on here? Okay, sorry about that. Let's get back. Technology's wonderful most of the time. So probability prefer Popeyes and Chick-fil-A. That's a joint frequency, so where those two meet, that's 29. That's going to be 29 out of 185, and we can approximate that to about 16%. All right, what is the probability that a randomly selected U.S. adult does prefer Popeyes or does prefer Chick-fil-A? Again, that's a union. It's going to be the probability of Popeyes plus the probability of Chick-fil-A minus the probability of both, so those people aren't counted twice. Popeyes, it's 107 out of 185, plus Chick-fil-A is 82 out of 185, minus both would be 29 out of 185. That's going to give me 160 out of 185, like one or the other or both. That's going to be approximately, 86%. Okay, what is the probability that a randomly selected U.S. adult does not prefer Chick-fil-A? Just C prime, and prefers Popeyes. That's going to be a joint frequency. I should be able to pull that from my table. So C prime of P is 78 out of my table total, which is 185. That's going to be approximately 42%. Do some conditional ones. Given that a randomly selected U.S. adult does not prefer Popeyes, what is the probability that they prefer Chick-fil-A? All right, again, it's the probability of both, so C and P prime, over the probability of your condition, which is P prime. All right. So 53 out of 185 prefer Chick-fil-A and not Popeyes. People that prefer or do not prefer Popeyes is 78 out of 185. Complex fraction, denominator is the same, they cancel out, so I'm left with 53 out of 78. That approximates to 68%. All right. Given that a randomly selected U.S. adult does prefer Popeyes, what is the probability they do not prefer Chick-fil-A? All right. Again, that's the probability they both occur, so C prime and P over the probability of P, the condition. Okay, C prime and P is does not prefer Chick-fil-A and prefers Popeye, that's going to be, if I pull that from my table, 78 out of 185. And the probability they prefer Popeyes is 107 out of 185 again. Now they just cancel out. I'm left with 78 divided by 107. Approximates to 73%. So this concludes our lesson for two events, organizing them into a Venn diagram or a two-way table, a contingency table, and then calculating probabilities based on the information. Questions that are similar to this or that use these particular skills, you could work through question number 3 from the 2019 AP test and question 2 from the 2011 test, just to test out your skills and see if you can go ahead and work through these skills to solve these answers correctly. If you're a teacher and you like this lesson, you can visit my store at that address, at that website. And I have curriculum for both AP Statistics and Introductory Statistics. Again, thanks for joining me for this AP review, and I'll see you at the next one.